Hi guys, welcome to our lesson. So today we are going to look at one of the aspects of errors that we had discussed in one of our introductory videos. We had said that an error, of course, the concept of studying errors is going to assist us in trying to figure out how we can be able to quantify uncertainties. So in this case, we are going to move a step ahead and try to look at statistical analysis of random errors. And this is going to assist us to figure out how some of the formula that we have already applied in some of the videos that we have discussed on statistics work. So for today, we're going to look at how we can be able to do some analysis of random errors and some of the concepts that are going to be, of course, related to the same. So for that case, thank you and welcome. So as I've said, today's topic is basically going to be a concept of on errors, which basically I've said is a statistical analysis of random errors. And we're going to see that from this statistical analysis of random errors, we're going to find some of the ways or the formula that we can use to describe these concepts that we named as uncertainties. So I'm going to have this one as a statistical analysis of random errors. Now I'm going to have just a small reminder of what we have mentioned in our first video on the concept of random errors. And we said that after this, from the three categories of errors, we said we have gross errors, and then we have systematic errors, and then lastly we said that we have what we call the random errors. So in this case, we said that there are some specific procedures that we can be able to use to minimize these two first categories of errors. And in an essence, we said that after all the parameters from this first and second kind of data, or rather kind of errors have been rectified, there still exists some errors that may result from either noise or maybe fatigue of the person who is working with the data. And therefore, we are going to see that these errors, as we said, are going to display themselves as either positive or negative deviations. And therefore, these are going to be corrected, as we said, by taking a large number of readings and therefore trying to treat this data from this specific point to minimize this issue of errors. So therefore, from that point, we are going to look at this specific concept of a statistical analysis of random errors. And we said that if a physical quantity such as length or perhaps time is measured with maybe a stopwatch or a meter rule, and therefore we're going to see that these readings, as per this case for random errors, if you're trying to minimize the error in these two specific parameters, then we're going to see that a number of readings are going to be taken, and we're going to obtain a data that is going to have a distribution of readings which vary due to the cause of random errors, of course. There's going to be deviations which is going to be displayed by these specific readings from the value that we're going to mention later due to the this concept of random errors. Now for such a kind of data, we're going to see that we're going to take an average or a mean value in order for us to try and find out a value that is almost, or rather that is almost approaching the true value. Therefore, in this case, if we try to look at what I've said about the obtaining the average, or what we refer to as the mean, therefore this is going to be obtained from this specific reading, taking the number, the total of these specific readings divided by the number of those specific readings or the occurrence or the trials which have been done in that particular readings, first, second trial, up to the number of trials. So that this is going to be the sum of the individual readings divided by the number of trials, which is going to assist us obtain what we call the average, or rather the mean. Now, if we try to give just a summary or the formula that is going to be used for this particular case that I've mentioned for average, or mean. In one of our videos on the concept of measurement of central tendency, we talked about this concept of the mean, and we said that for grouped and ungrouped data, there's a formula that we can be able to use to measure this particular mean. So therefore, we are given a formula for trying to find this specific kind of a formula that we had said is the mean. Therefore, we give it an initial as x with that specific symbol there implying the mean. So therefore, the mean or the average was given as this is the summation of the data that we are going to, of course, obtain from the first to the nth one of these specific values of measurement that we give as such. So in this case, I've given the first initial, that this is the x, which has got that specific symbol implying the mean, whereby we are going to see that in this particular case, n is going to imply the total. This is the totals of x values, which of course I've given as that, and this is going to imply the mean, whereas these x values that I've indicated on that specific a part of the formula, this is going to imply each value of x in the data, that specific range of data, and therefore this specific symbol that we've used is going to imply the sum of. Therefore, this is going to give us a formula for trying to find the average of that specific range of data that we are calling. So that is one of the strategies that we're going to use in trying to analyze data. Now, of essence for us is that we're going to see that this specific the name that we have used for the mean is going to assist us somewhere in trying to figure out some of the characteristics of this specific data. Now, of course, we're going to use to see that as we are going to take the number of readings to be more, as we said, in order for us to reduce the concept of random errors. I can just use an illustration here that perhaps this is the readings that we have obtained from that specific data. And if we say that this is a true value, which is x, and then we are trying to measure, to make some measurements, this distribution of readings here, these are the values of x, this specific symbol, and then this is a true value. We're going to see as the number of readings increase, the average is going to move towards the true value, and therefore that is one way in which we're going to reduce these instances of random errors. Now we can be able to, of course, see that this specific case that I've discussed normally apply whereby we have what we call systematic errors, and we're going to see that a spread of the measured values about the mean is going to imply the concept of high precision. And from our discussion on measurement in one of the videos, we talked about the concept of precision, and we said that this is the quality or the condition of being exact or accurate. Therefore, as more readings are taken, then therefore we're going to move towards accuracy. Now, there are two specific concepts that I'm going to add apart from this, so that we can be able to see some of the ways in which we can be able to analyze this specific random data, random errors. And I'm going to do away with this so that we can be able to have a discussion for that. Now I'm going to use the sample data that I've provided on the board in order to find one of the ways in which, apart from the mean that we have spoken about earlier, to see one of the ways in which we can be able to do some statistical analysis of these random errors, or one way in which we can be able to characterize this specific mean that we talked about given this range of data. So we are going to introduce the concept of standard deviation. Standard deviation. As I said, we have discussed one of this one. I'm going to put a link of these specific videos in our description box. So in this case, we're going to introduce the concept of standard deviation apart from the mean that we have discussed. And in this case, I'm just going to give a formula for this. So we say that standard deviation is given as this is sigma. No, this is delta. So delta. So we're going to use this Greek symbol for delta in order to denote a standard deviation. And the standard deviation is going to be given using the formula of this one, now that we've discussed the concept of n. So that is going to be given as the root of 1 over n minus 1. So I'm going to elaborate on this. This is the summation of from I is equals 1 to n. And this is x minus x squared. So this is the formula that we use for describing what we call a standard deviation. And in this sense, of course, I've said that the delta is going to be used to denote this concept of a standard deviation. And therefore, from this, of course, we have talked about the n is the number of the, of course, the total values of n, the total values of the xi that we have indicated from our previous discussion on this specific topic. And then I've talked about the concept of xi. This is a range of course, each value of x in the data. And this specific symbol represents the summation of, and lastly, we're going to see that this I is the initial, of course, point, or the point from where we are going to start from. And therefore, this is the way in which we can be able to find. Now, to elaborate using this specific range of data that I've said, we'll assume that these are the trials or the measurements that were initially taken from the several readings that we have done. This is, of course, 1, 2, 3, 4, 5, 6 trials that were done. It was obtained that it was found that from the 6 trials that were done, of course, the average, which of course is the, as we have given this specific symbol, was obtained to be this value, which is 5.04. And then next, we're going to see that for us to find the deviation from this specific data, we're going to find the difference between this specific mean and the value for x that was obtained from the first trial, second trial, respectively. So this is going to coincide with this column. So if you see the difference between the second one is 0, the first one there's 0.01, and lastly 0.01 there. So therefore, we're going to see that for us to find the figures for this, we're going to have a column that is going to consist of this specific square of deviation, and therefore this is going to be the one that is going to assist us to find this summation at this specific part of the formula for standard deviation. Of course, we can work other examples, more of these examples using the same formula. Now, therefore, this one is just for illustration. So the first thing you find from the trials, you find the average by finding the summation over x from the initial, of course, to n number of x also. You just give it correctly. We talked about the concept of the mean. So we're going to find that the mean is going to be the summation from I1 to n of the x values divided by the number, of course, which we say the totals of values of xi. So therefore, that is going to give us what we call the average. So the difference between this, that was, so this is going to give us the first, the second column for this. So the difference between this first and second column is going to give us the deviation, and then the square of this third column is going to give us the square of the deviation, which we are going to use in this specific part of that standard deviation. So the concept of standard deviation, apart from the mean, is one of the strategies that we can use in order to analyze this specific random errors. So we're going to see that as the value of the standard deviation becomes small, the spread of the measured values therefore is going to indicate high precision. Now that I've talked about the concept of precision, so of course the attendance of or the quality or the condition of a fact or a factor of being exact or accurate. So therefore, apart from the mean, this is the second one, and we're going to look at the last, or rather the last two concepts on how we can be able to obtain other ways of analyzing these random errors. Now, from the previous data, of course, I've avoided working this specific example because of space, and as I said, I'm going to put a link over the video that we're working on those specific one or two examples for finding the standard deviation. Now, in this case, if we're going to see that if we are trying to find what we call, this is the concept of errors, if we are trying to find a way in which we can be able to express that specific mean that we say is 5.04, and then therefore we're going to have an uncertainty that we're going to link with this specific recording for the mean, and therefore we're going to see that the error of uncertainty and this mean value is going to be referred to as the standard error. And of course, this standard error has got a formula, and it's going to be designated as the standard error, which is going to be given as, and now that we have defined these specific sections for the standard deviation and the number, total number of the x values given as such. So this is going to be the formula that is going to be used to denote the standard error, and it's one of the ways in which we can be able to do an analysis of those random errors. So a good approximation for this specific standard error that I've said is going to be, of course, reported using this specific reading. Now, for instance, if we say that the reading was 5.044 for the mean, therefore we're going to indicate either positive or negative for this specific standard error. Now, we're going to see that there is a condition in that in trying to give an expression for this specific error that we refer to as standard error, we're going to see that it's going to be expressed when the number of readings is going to exceed or be more than 6. So for n, which is of course equals greater than 6, or perhaps okay, perhaps let's just give that condition for it for now. So if the number exceeds 6, then therefore we're going to give it to indicate this particular expression for the standard error, which is going to be given as either an approximation of a positive or negative standard error. Now, for a lower number of readings, apart from which are of course less than 6, as we say, we're going to use another, of course, method which is referred to as the mean absolute deviation. Now, the mean absolute deviation as well is one of the ways in which we can be able to express or characterize this specific data. Now, I'm going to give a formula for this also mean absolute deviation from the range of data that, and of course the denotations that we have used for this mean, standard deviation, and of course the standard error. So therefore, I'm going to give it an initial as mean absolute deviation, which is going to be given as the positive or negative. This is of course we have said this is a summation from 1 to n of this specific division that we have given as such. So this basically is going to give us a specific value which we are going to express in our expression that we have said for range of numbers which are less than 5, less than 6. So that whatever value that we're going to obtain from this particular case, instead of expressing it as a standard error, which I'd say is given as this, we're going to use the mean absolute deviation from the result from that specific expression. Now, in this case, having talked about those ways in which we can be able to do an analysis of random data, we can see that there's a correlation, a relationship that exists between this particular discussion for random errors and the concept of statistics that we had already discussed in one of our videos. Now we're going to see also that this is going to extend further to the other errors that we have talked about, but of course that is going to be a discussion for another day. So therefore, from our discussion, I've said that for us to do an analysis of these random errors, we're going to include the concept of the mean and try to see how the figures, the data spread about the mean. And I said that the mean is given us the summation from 1 to n of the values of x given as such. And next I said that we can be able to express this characteristics, this specific mean by using the concept of standard deviation. And I said that the standard deviation can be given as the root over 1 n1, the summation 1 to n x minus. This is the deviation squared. So therefore that's going to give us the standard deviation. And then we talked about the concept of a standard error, which we said this is an error of uncertainty in the mean value of x that we had said. So therefore it's going to be given us the standard error, which is the standard error given as such. And lastly, we have talked about the concept of the mean absolute deviation, which is also going to be given as positive or negative, the summation of the values from 1 to n this specific deviation. I can just give them as such. And therefore, this is going to be expressed for numbers which are less than 6, and this is for numbers which are more than 6. So I hope that these 4 concepts are going to assist us in trying to figure out how we can be able to analyze random errors and some of the areas which is going to be have a relationship with our topic for discussion for today. So that is it for today, guys. Bye. God bless you.